Okay, Sam, this one kind of sucks, but bear with me. What we're gonna do is we're gonna bring this 1 over to the other side because notice the other problems were always a 0 here. So we're gonna subtract 1. Now that's gonna give us 1 plus x over 1 minus x. That didn't change at all. That's the same as that. And then I have a minus 1 is now greater than or equal to 0. All right, what we have to do now is we have to combine these two terms, which is a little bit of a pain, to be honest, but we're gonna handle this. In order to combine fractions, we actually need to have a common denominator. So whatever value this is right here, I'm gonna put this over the same exact number, but that's not allowed in math unless you do it as well to the numerator. And the reason why is because the only thing we can do is multiply by 1. And if this is the same thing divided by the same thing, that's 1, okay? So the next thing that we're gonna do here is when we have two fractions that have the same denominator, like 1/8 plus 2/8, what we always do is keep the denominator and then we just add the numerators. In this case, we'd have a 3. So what we're gonna have here for the next step is the denominator. We had 2 8s, it became 1/8. Same thing here, we've got these and it's gonna become 1 fraction of 1 minus x. And I'm just gonna copy down that greater than or equal to 0. Now here, I've got a 1 plus x, and then I'm just gonna copy this down right here. That gives me a minus 1 times 1 minus x. It is crucial that you put parentheses here. That's kind of a trap. Okay, now our favorite property, the distributive property. So we're gonna keep the 1 plus x. Then I have minus 1 times 1 is a minus 1. And then minus 1 times a minus x is a plus x. All over 1 minus x. I've done absolutely nothing here, but all I've done is just distribute that through. Okay, now let's go ahead and simplify. A 1 and a minus 1, they actually cancel. And an x plus an x is a 2x. Okay. All right, now for this problem here, you're gonna now find your zeros and your undefined spots. The zeros come from finding when the numerator is equal to 0. So I'm gonna set 2x to be equal to 0. I divide by 2 and I get x equals 0. This is what we call our zeros. And these are problems that actually make the function equal to 0. So this is when our function's equal to 0. They are allowed. The denominator is a different situation. This is actually where our function is undefined, meaning that we cannot have certain values in our denominator because we cannot have 0 in the denominator. So in this case, I'm just gonna add x to the other side. Okay, the 1 stays the same and I get 1 is equal to x. And really what I mean here is x cannot be 1. Because look here, Sam, if I did 1 minus 1, that would give me 0 and I cannot have 0 in the denominator. So now when I create this number line, I'm gonna create it with these two values, but notice that I can have the 0, but I can't have the 1. So when I put this, I'm actually gonna say that I cannot have the 1 because the 1 is the thing that's gonna make this denominator 0. Now it's really important to note that this is the equal to symbol, and this wants to know when we are also equal to 0, and that's gonna be when x is 0. Because if I plug this in, I get 2 times 0 is 0, divided by 1 minus 0. So this would be 0 divided by 1, and yes, that is 0. So the only reason I'm putting a check mark here is because of that equal to symbol. If that equal to symbol was not there, then by plugging in this number into our function, we would have gotten 0. And if that symbol wasn't there, we would not include it because that wouldn't be part of the solution. But because it says equal to 0, that is a solution. I put a check mark. Okay, now we're just plugging in numbers to the left and right. And this I find a little bit easier actually. So I'm gonna put in a minus 1. Here we'll put in a 1/2. Here we'll put in a 2. And honestly, these numbers don't matter at all. So again, we're just gonna get a general idea of negative or positive. I take that minus 1 and I plug it in for both of these x's. So 2 times -1 gives me a negative, divided by 1 minus -1. Be careful, that's 1 minus a -1. Well, that becomes 1 plus 1 is 2, which is a positive. So here we have a negative divided by a positive, which is a negative. Okay, now here we're plugging in 1/2. 2 times a half, who even cares? It's 1, but 2 times a positive is going to give me a positive. Now plugging in 1/2, I get 1 minus a half. That's also positive. So positive divided by positive is a positive. Okay, last one. Let's take 2. 2 is in between 1 and infinity. So let's take in 2. 2 times 2 is 4, which I don't care about the 4, but I care it's positive. Then 1 minus a 2 is actually going to give me a -1, which is a negative. So now I have a positive divided by a negative, which gives me a negative. So going back to the original, this problem is all about being greater than or equal to. So I'm looking for my positive values or my solution. So my answer is going to be from 0 to 1. Now because I am allowed to have 0, I'm going to close bracket. And I cannot have 1, so that's going to be an open, but I want everything in between. Again, why am I allowed to have 0? Because when you take 0 and you plug it in, you get 0. And because of this equal to symbol, that means it's part of your solution because you're allowed to be equal to 0. And that's what plugging in 0 gives you. Versus 1 is not part of the solution. It's actually not part of the domain, so it can't be part of your solution. Because when you plug 1 in here, you get 0 in the denominator, so that's bad. Again, why did I choose plus? Because of the greater than symbol right there. All right, so this is your solution right here. Best wishes. Math is fun.
Good luck.